It takes Jupiter 9 years to rotate once on its axis. Why? In this video, we'll find out. As usual, our solar system formed from a giant cloud of gas and dust. Over time, gravity caused this cloud to collapse, and as it collapsed, it started spinning faster and faster, like a ball when you let go of it after kneading it with your hands. This is called the conservation of angular momentum. As the cloud collapsed, it also flattened into a disk. The majority of the mass was in the center, and the flattened edges were thin and had less mass. But that's not the end of the story. Gravity acted on the mass in the disk, pulling it towards the center. But there was already a lot of mass in the center. So instead of going into the center, the extra mass just bunched up around the equator of the young planet, making it wider at the equator. A similar thing happened with Saturn, Neptune, and Uranus. All the planets in the solar system have a slight bulge at the equator due to the conservation of angular momentum from the spinning disk of gas. But Jupiter is special because it has an extreme bulge. It is so wide at the equator that if you were to roll it across the surface of the sun, it would touch the sun's surface on both sides. How did it get so wide? Well, the answer lies in what Jupiter is made of. Most of Jupiter is liquid metal. Imagine stirring a cup of coffee. It's easy to stir it if it's low viscosity, but harder to stir if it's high viscosity. It's almost impossible to stir honey. If you can stir these liquids, you'll notice something. You can easily change the direction of honey. But it takes more effort to change the direction of water, which takes even more effort to change the direction of the coffee. This is because the more viscous fluid has more resistance to changes in motion. It's harder to speed up or slow down. It's also harder to change its direction. Now, imagine you are stirring a very viscous fluid like honey. When you stop stirring, it takes a while for the honey to set. This is inertia! It wants to keep moving the way it was moving. The same thing happened to the fluid on Jupiter. After the planet formed, the fluids wanted to continue rotating the way they were rotating. However, because they were so viscous, they couldn't quickly change their motion. This means that some of the fluid near the poles was being pulled down to the equator where most of the fluid was. However, over billions of years, the fluid slowly moved from the poles to the equator due to inertia. Now, imagine stretching honey with a toothpick. The longer you stretch it, the thinner it gets. The same thing happened to Jupiter. The centrifugal force from the spinning planet stretched it outwards, and the viscous force from the fluids tried to keep them in place. Eventually, the centrifugal force won over the viscous force, and the planet stretched so much that it deformed the shape of Jupiter. If you look at Jupiter from the side, it looks a bit squished. This is exactly what happens when a planet rotates so fast that the centrifugal force is greater than the gravitational force. The gravitational force pulls everything towards the center of the planet and makes it round. But if a planet spins fast enough, the centrifugal force pushes everything away from the center and makes it look squished from the side. So how long does it take for Jupiter to rotate once? Well, it's hard to say exactly because it's not rotating uniformly. Different latitudes rotate at different speeds. The equatorial region rotates the fastest, and the poles don't rotate at all. There are regions between the equatorial region and the poles where the rotation speed is in between. These regions are intermediate in their rotation speed and are called shear zones. Scientists used to think that Jupiter formed from the collapse of a single giant cloud. But now they think it formed from the merger of smaller clumps of gas. If that's true, then why doesn't it look like it's wobbling as it rotates? Well, think about it. If you were to throw a ball straight up, it would wobble because it has angular momentum. But if you threw it with a slight spin, it wouldn't wobble. The spin of the ball cancels out any wobble caused by its angular momentum. The same thing is happening to Jupiter. Its spin is canceling out the wobble from its formation. But there's one big difference between the ball and Jupiter. The ball slows down as it goes up because of air resistance. But Jupiter is in space, and there's no air resistance. So it will continue spinning forever unless something changes. But that's impossible because it's made of gas. Nothing can change until it runs out of hydrogen and becomes a white dwarf. And that's 20 billion trillion years away. So we can enjoy the amazing view of Jupiter for billions of years to come. Once again, thank you for watching. If you enjoyed the video, please subscribe and leave a comment. Also, check out our other videos. One of them might make your day.